The next question we need to ask is whether temperature is the only thing we need to worry about when we're trying to understand thermal processes. And there are a number of experiments that suggest that that's not the case. First off, if I take a small cup of water and put it in a room, it will cool down to room temperature. Okay, that's what we see here. By contrast, if I take a much larger bucket of water and place it in the same room, same temperature, it will also cool down to the temperature of the room, but it will take much longer to do it. So there's something going on beyond just temperature. A hot object does cool down to the temperature of the cooler room, but the amount of time it takes depends at least on how much stuff is there. Furthermore, if I take that same small cup of water, I can put it into a thermos, which I'll just draw very schematically, and it will still cool down to the temperature of the room around it, but again it will take much longer than if it was just sitting out on its own. And perhaps the most exciting one is what happens if I take some ice water. You know that something cold and perhaps the most dramatic is what happens if I take the water and I place it in a very cold freezer where it's going to freeze. The temperature, of course, drops until it reaches 0 degrees Celsius. It doesn't drop straight down to the temperature of the freezer. And something very odd happens at 0 degrees Celsius. So long as we keep it well mixed, the temperature holds fairly constant right there at 0 degrees Celsius. It doesn't change for a long time. And then, once all of the water becomes ice, which is what's happening here, the water is becoming ice while it holds at this temperature. Once all the water is ice, then the temperature starts to go down again. So all of these suggest that something is happening beyond what can be explained just in terms of temperature. Before this was fully understood, people would say that a substance known as heat or caloric was passing from one object to another, and the amount of time depended on how quickly the caloric passed and how much had to pass. There's a couple other experiments we can do to show that it's not really a substance. We can take a container of water and put it on a burner. We know it takes fuel, an energy source, to heat the water on the burner, so we know we're adding energy to it as it heats. Also, we know when we rub our hands together and they get warm, we're adding energy by rubbing. And if we have two containers, one large, one small, it takes more energy, more fuel, to heat the warmer one. So that suggests that this quantity that I referred to as heat or caloric is not really a substance, but rather it's an energy. So we call this process heating, and it's the transfer of energy from a system with a higher temperature to one with a lower temperature that is in contact. They don't even necessarily have to be in direct contact. They need to be in thermal contact. And that change in temperature occurs simply because of the temperature difference between the two systems. Oftentimes, we will talk and say we are adding a kind of energy known as heat. Now, the author of this text doesn't like using that way because a lot of people confuse heat and internal energy. I want to introduce you to the term, and I will often refer to the amount of energy that is passed from one object to another in this heating process as the heat. But I want you to remember that heat is an amount of energy that is transferred. In that way, it's very similar to work. You remember, I told you if I ever ask you how much work does this baseball have, the proper answer is that's a stupid question. Because work is an energy transfer related to a process. Heat is also an energy transfer related to a process.